This video will be on angle relationships and also how to find the measure for some of those angles. For the diagram that's shown here, we are going to use the instructions that ask us to find the angle relationship, so this part, and also the measure. For the first one, we're asked to look at angle ATB. So you just follow the directions that are given and look at the notation. Make sure that if you're writing that down, that you put the little angle symbol. And it also wants us to find the relationship between that one and angle BTC. So this is what it looks like together. If I notice, I see this right angle mark, and that tells me that this entire angle is going to equal 90 degrees. Well, I know that the rule or the definition for two angles adding together to equal 90 is called complementary angles. So that's what they're asking for when you're asked about the angle relationship. So complementary angles. Again, that's when two angles are added together to equal 90 degrees. Now, if I go to the next portion, it's asking me to find the measure of angle ATB. Well, I need a little bit more information. So if I look above it, it tells me that the measure of angle BTC, that portion is going to be 74 degrees. Notice when I am writing just the name versus the measure, when I have an actual degree with it, that I now have included the M in front of the angle mark. So I'm going to go ahead and label my measure of angle BTC as 74 degrees because that's what was given. And since I already know that they're complementary angles, that means that I'm going to take 90 degrees and I'm going to subtract the given information, 74, in order to find the measure of the remaining angle, the measure of angle ATB, which is going to be 16 degrees. So I take that information, and again, I just go ahead and label the figure that's shown because I might need it for something else. If I continue, I'm asked to look at the measure of ATB again, and what is the relationship with angle FTE this time? So again, angle ATB and angle FTE. I'm just following the order that's shown. What I will notice is I have two intersecting lines that are shared by one vertex that have created what's known as vertical angles. I've talked about this in class before, but vertical angles are congruent. So if that one angle is 16 degrees, so is this one. If you look at it, for me, I'm visual, it looks like a little bow tie. That's how I see it. I also see, if you turn your paper, I see this is a V and this is a V. And like I said, they just share the same vertex and they're congruent. All right, chugging along. Oh, what do we call those? We call those vertical angles. So let's go ahead and write that down here. And I'm just abbreviating the angles there. And then I'm asked to find the measure of angle FTE, which is what we just did. So that's a vertical angle, so therefore they're congruent. The next portion of this asks me to find the measure of angle CTE. So CTE. And if I look at that, I can see that it's actually on the same line as this right angle mark. So if that's the case, by default, this side is also 90 degrees. So I'm just going to go ahead and label that as 90 degrees. And you'll notice on most of your figures, when you see this, they won't draw the 90-degree angle or the right angle on both sides. It's just one or the other because it's understood that this is also 90 degrees. Now, does that make sense? If I were to actually look, again, I see a line here. What do I know about a line? I know that if I add all of those angles together, they should equal 180 degrees. This is an example of a straight angle. Keep that in mind. Okay, let's go on to what's being asked here. So we said the measure of angle CTE was 90 degrees. So we're going to go ahead and write that down. And notice I'm writing my degree symbol each time I talk about the measure. So make sure you do that. And then finally, we're going to look at angles ETF and angles FTA. This angle ETF and angle FTA. And what is the relationship there? Well, what I see is that I have created a linear pair. Pair because there's two angles here, and linear because they're on a line. So linear pair. Let's go ahead and write that down really quick. And then what I see is it's asking me to find the measure of FTA, because angle FTA, because we've already found the other angle, or we know the angle. Now, remember, a linear pair means that once I add those together, it's going to equal 180 degrees. So if I already know that, 180 degrees minus the angle that I know, which is 16, will tell me this angle that's currently missing, which is angle FTA. Once I subtract 16 from 180, I see that this angle is 164 degrees. So that's what we're going to put right here. And not only is this a linear pair, I have two angles that have added to equal 180 degrees. Well, you know that that's the definition of a supplementary angle. So in addition to creating a linear pair, I also have what's known as supplementary angles. So I've told you this before in another video, but some people still get it mixed up. If I am asking which one is the 90 degrees and which one is the 180 degrees, the two angles that add to give me 90 are complementary, and the two angles that add to give me 180 are supplementary. What do you notice? C comes before S, 90 comes before 180. So that's how you know which one goes with which. And if you were actually writing this out for the supplementary one, you would have said the measure of angle ETF plus the measure of angle FTA equals 180 degrees. Okay? Like and subscribe. Have an awesome one.